Hello all, welcome back to my channel in the journey to learn data science. So in continuation of previous series of videos, we have used linear regression and we have studied different types of encoding techniques. So today we'll be seeing how do we implement linear regression in Python. And the problem we have taken is to predict the selling price of second-hand cars. So let's begin our journey in the practical hands-on session of Python. So to implement Python, we need some basic libraries that are pandas, numpy, matplotlib.pyplot, cbon. So these as PD. So if we have written import pandas as PD, now this PD is an alias of pandas. Alias means that if we are invoking pandas library, then we don't have to write pandas again and again. We can just write PD and the name of the function and the method will be invoked. So we have imported libraries, all these libraries, pandas, numpy, matplotlib and cbon. After importing these libraries, we can run this cell using the control plus enter command. Now, after loading these libraries, we have our car dataset. If you want to have a look of car dataset, so this is a dataset we have in which we have attributes as car name, year, selling price, present price, and so on. So we have imported our dataset using a command that is pd.read_csv, and this is the name of a dataset. And after executing this, data is the data frame that we have created of this dataset. Now there's a brief description about the dataset we have, that is the number of attributes and the name of the attributes that we have just seen in the dataset. Now we want to check these attributes and the type of data these attributes have. We have a command data.head. So data is again the data frame that we have created, and head is a command to display the first 5 rows from the dataset. So if we'll execute this command, we can see that our dataset with first 5 rows is being displayed. That is having car name, year, selling price, present price, kilometers driven, fuel type, and so on. And the 5 instances of our dataset. Next, if we want to display the last 5 rows of my dataset or last 10 rows of my dataset, I have a command data.tail. So to display the rows from the last, we have a command tail. So if I write 5 here or if I leave blank here, so it will automatically give me last 5 rows. So if I write number of rows as 10, so it will display as last 10 rows. So it is up to us how much data we want to display. Next, to check the number of columns and the number of rows in our data frame, we have a command data.shape. So if we'll execute this command, we'll get that we have 301 rows and 9 number of columns. And then we finally want to print the summary of our data frame. Then we have a command data.info. Again, data is a data frame that we have created using our dataset, and info is a command to print the summary of my data frame. So in the summary, we have 301 rows, 9 columns, the name of the columns, the type of the column, that is, it is a categorical variable, integer variable, or a float variable, and whether we have null values or not. And at the end, we can see that we have 2 floating point data types, 3 integer data types, and 4 categorical data types. So last is to check whether we have any missing values in a dataset. We can see from the summary that we don't have any missing value. Still, if we want to find out, we have a command data frame name, that is data dot is null, and if we want to sum up all the missing values, we can write sum. And if we'll execute this command, we can see that none of the column has any missing data. Last, we want to describe the statistical characteristics or information about our data attributes. So we use a command describe, data.describe. This gives us the following information. That is number of instances each column has, what is the mean of that particular column, what is the standard deviation, what is the minimum value, which is the 25% quartile range, which is the 50% quartile range, and so on. This method or this statistical information is very useful in finding out the distribution of our data, whether it is normally distributed or it is skewed distributed, and to find out outliers. This we'll see in the next upcoming video. So further, now we want to find out whether which attributes we want and which attributes we don't want. So let's say car name. Car name does not have any role in selecting the selling price of our car. So we want to drop this column or we want to delete this column from our data frame. So for that, we have a command data.drop, and whichever column we want to drop, we will write the name of that particular column and our column will be dropped from our data name. So car name has been dropped from our data frame. Next, we'll see what all categorical variables we have and what all numerical variables we have. So for that, we will check the data type of the column. If the data type of column is of object category, that we have seen in the information part as well, in the object category, then we can say that variable is categorical variable, and if that data type is not of object category, that variable is a numerical variable. So we will run a loop for all the columns in our data frame, and if the object type is the data type of a particular column, we will calculate it as a categorical features. So we can see that fuel type, seller type and transmission are the categorical variable. We can confirm it from the data type as well, that fuel type has categories petrol, diesel, seller type has dealer, and transmission has manual. So these are the only 5 rows that we are displaying. There are more number of categories in it. Next, to find out numerical features, we will again run the same code with data type not equal to object type. And we will run this code and we can see that year, selling price and rest of the attributes are the numerical features. Now we know that to apply linear regression, we have to convert these categorical variable into numerical variable. So let's see how do we do that. So this is a code to plot my categorical type. I want to see which number of rows have more number of category. So I am displaying my categorical features and now I am plotting it using the count plot. So count plot is a function in the Cborn library. So we have invoked sns.countplot and then we are plotting our categorical variable. So you can see that in fuel type, we have 3 categories, petrol, diesel and CNG. In seller type, we have 2 categories that are dealer and individual, and transmission we have manual and automatic. So we came to know what all different categories we have in these kind of variables. Now our aim is to convert this categorical variable into numerical variable. So in my previous video, you must have seen the one-hot encoding method to convert this categorical variable into numerical variable. So we are applying the same method here. So we are using pandas library and we are using the function get dummies. So a dummy variable will be created for each type of category for each variable. So you can see that after running this command, we are getting fuel type CNG, fuel type diesel, fuel type petrol. So we have a new column for each type of category in that particular variable, and our dataset will move on like this. But we can see that if a vehicle is of CNG type, then it will not be of diesel type or a petrol type. If a vehicle is of petrol type, it cannot be of diesel or CNG type. Similarly, if the seller type is dealer, it cannot be individual. And if the vehicle is automatic, it cannot be in the manual mode. So we can delete one attribute or one category from each categorical variable. So to delete one attribute, we will implement a code and we will select the attribute that we want. So let's say in this fuel type, we have selected 2 attributes only, CNG and diesel. And if the vehicle is not falling in any of these categories, then automatically it is of petrol type. And similarly, we will do it for the rest of the variables, that is seller and transmission. So after selecting these attributes, we are feeding it as an input to the X. Now X represents a data frame where we have the independent variables. Independent variables are those that are used to predict our output variable, right? So we have year, present price, kilometers driven, all these features we have in a data frame called as feature, and then we are feeding it as a input variable X. Now in Y, we are feeding the selling price as a output variable which we want to predict using linear regression. Now let's see what all X and Y contains. Then again we will use a command head x.head. So we can see that in X all the features that we have written over here are presented, and in Y we have only the selling price. Now our aim is to divide this X and Y into training set and testing set in order to apply linear regression. Now to divide our data into training set and testing set, we will import a library called as sklearn model selection, and in this particular library we will import a module called as train test split, so that we can split our dataset into training part and the testing part. So here we are invoking this method and we are dividing it on the random basis. So we have four things now. The two training set, that means X training set, which is our input training set, and the Y training set, which is our output training set, and the test set of X and Y. If you want to check the shape or the number of rows that each training set and testing set has, we can use again shape command, xtrain.shape, ytrain.shape, xtest.shape, and ytest.shape. Now I will execute this so that we know that xtrain and ytrain has 225 number of rows and test set have 76 number of rows. Now the training set of X has 8 number of columns and the Y has only one column, that is selling price. So this is how we can confirm how many rows of data is divided into training set and into the testing set. Next part is to apply linear regression model. Now to apply linear regression model, we will import a library sklearn.linear module, and from this we will import linear regression method. After importing linear regression, we will create an instance of linear regression and we will pass the training data xtrain and ytrain. If we will execute these, we can get a output as linear regression. That means a linear regression has been successfully applied on our training data. Next, we will predict the value of testing set and testing set on the X. So we will apply a method predict on the X test, and then we will calculate a score on the training data set. Now, if we are after prediction on the X test data set, we are finding out a training score, and we can see that our training score is 87.99. Now we will train the score on the testing set, and then we can execute our data, and we can see that on the test set we are getting a prediction of 86.08% of accuracy. So after finding out this prediction on the Y test data, we can model it using a scatter plot. So to plot a scatter plot, we are using the matplotlib library. So we were using an alias of plt here. So plt.scatter, and we are passing the Y test value, which was our actual value in the dataset when we were dividing our dataset into training set and testing set, and this is our predicted value, right? So we have already know what are the actual value and predicted value, and then we are plotting our scatter plot. So this is a scatter plot that we have received. After plotting the prediction values of the Y set, we can evaluate our model. To evaluate our model, we need to import some metric module in which we have mean absolute error, mean squared error, then we have root mean squared error, and the R squared statistics. We have all studied this in our previous video. So if you have not referred to this previous video, kindly go and check it out. So we will import the sklearn library and we will import a matrix module, and then we will just have to write the name of the function, that is matrix.mean absolute error, and we need to pass the actual y value and the predicted y value for all these parameters. After we will writing the code, we can execute this and we can see the final results of MAE, that is mean absolute error, root mean squared error, and R squared statistics. So we know that more the R squared statistics, better is our model. So this is how we can implement linear regression in Python for any kind of data set. If you find this video interesting and for more hands-on session, do comment me in the comment section and stay tuned to my channel. Thank you all.